How many times have you faced a test suite where hundreds of tests were failing with no clear reason why? What about this? How many times did you wonder what's the actual code coverage for the 50 different services that you are working with? Or why suddenly your entire test pipeline takes 4 times longer to complete? Today, I will share how we solve these type of challenges and more using observability in testing. Let's open this black box together. First, I would like to give a huge thank to the organizers for giving me the absolute pleasure to kick off this conference. I would also like to thank my friend Dario that helped me with the design of these slides. And I hope that you enjoy not only this talk, but the entire day ahead, which is packed with opportunities to learn, share, and connect with each other. So let's make this the greatest testing talks ever. So a little about myself. I've been working as a software tester for more than 20 years now. And I work at big companies like JP Morgan, Adidas, and Disney. And today I serve as a test architect at New Relic, a company that has an observability platform product. I moved to Spain from Argentina 4 years ago. I live in Zaragoza. And community is a big part of who I am. And that's why I organize testing meetups in both countries. So let's see the agenda for today. We will start by briefly defining observability in testing, then dive into the type of data that you actually need to make it work, before we wrap up with some real-life stories. So before starting, I would like to hear from you. When you think of observability, what comes to mind? Anyone would like to share? What do you think about when you think about observability? OK. Cool. User experience, metrics.
Logs and distributors.
Oh, wow. Yeah, totally. Thanks for sharing, or just for thinking about it. This is a formal definition of observability, so let's break this down together. One of the most fundamental aspects of observability is the ability to ask questions about your system, even questions that you didn't even think you need to ask. And it's not about collecting data for the sake of it. It's about having the flexibility to explore, research, and debug when things get tricky. And to do that, you need to dig into the state of your system. It's like taking a look inside this black box instead of shaking it and guessing. You want to know what's actually happening inside your system, what code is running, what type of queries are being executed. And to do that, you need to take a look inside the box by watching its outputs or external behavior. By taking a look at these signals, like how well your system behaves with a new release, or when new code is being merged into a main branch, this is how you will get an understanding of your system. 50 years ago, George Box said something simple but true. All models are wrong, but some are useful. And in testing, we use mental models to understand how our systems behave. And that's useful to a point, because today's systems are too complex. We need to find a way to actually learn from the system itself. And this is where observability will help us. If we compare monitoring with observability, we could say that monitoring is like building a model. We model for things that we expect to happen, like a CPU usage of more than 90%. When the alarm goes off, you know that something went wrong, and you planned for that. But what happened with those unexpected situations? for the things that you didn't expect. This is where observability kicks in. It will let you ask questions for issues that you never saw before. So monitoring is a reactive approach, while observability is a proactive approach. Monitoring tells you when something is wrong, and observability helps you figure out why. And why do we need observability in testing? It's the same reason that we need it in production. Systems today are too complex. We have microservices, micro front-ends, multi-cloud setups. We now even have a lot of code generated by AI and by coding, as Cameron said. So we need to have a lot of visibility into all of this complexity. Right now, not when things go live in production, but right here in testing. So let's go back to our black box. We can't just stand here looking at it, waiting for the answers to magically appear. We need to find a way to take a look inside it. And to do that, we need the essential signals of observability. We need to track the right data and make it available. So if you want to start with observability or you want to add observability to your test, I want you to remember one simple word, melt, where M stands for metrics, and these are just numbers, like the time it takes for a test to execute or how many tests pass or fail. E is for events. You can think of this as a key moment, like when a test finishes or when you merge code to your main branch. Logs is the full diary of what's going on with your applications and your infrastructure. And finally, traces is what connects everything together. It can help you understand the full journey of your services across all your requests. And today, we will be focusing mostly on metrics and events, because this is where we started our journey and where you could get the quickest wins. And at the beginning, it may feel like a little scary to start with the data, because there's a lot of things that we could do. It can feel like a machine with too many moving parts. But the big idea is this. You want to track the right amount of data to answer your future questions, but you don't want to track all your data because it will mean too higher cost. So don't try to track everything. Start small. I will show you two flows of how we track test data, test executions and code coverage in particular. So let's start with test execution. Our triggering event is when a test finishes. At that exact time, we get data that we attach as metadata to this event. And this data can be anything like the browser where this test was executed, the result, etc. We wrap that information and send it over to the observability platform of choice. And this is not an extensive list of the fields or the type of data that we track, but what we consider the most important ones. So if you want to start somewhere, you can start here. I will explain these three categories and why it matters. The first one answers the following question. Where did this test run? Right? If you track things like the environment, the build number, the browser name, and the base URL, this will help you understand and debug any issues or identify any sort of patterns, right? Bugs that happen only in one particular environment, let's say. The second group answers the question, who owns these tests? And this is really important. That's why we track the team that owns this particular test. So whenever something goes wrong or needs some work, we can route it to the right experts. We also track annotations. This is the tags where teams can add for experiments and features and anything that they would like to add to their tests. And finally, we want to know what happened with the test. And this is where we track the test result, the outcome, the duration, and any errors if there were some failures. When we track code coverage, the flow is pretty similar, but this time the event that is triggering the data collection is when we merge to master or the main branch. We don't want to track code coverage for every pull request or commit because that will be way too much data. We are only interested in understanding the code coverage trends when we merge to master. In the same vein, when we get this triggered event, we wrap all the data and send it over to the observability platform. We track code coverage for both UI and backend. And this sort of mechanism can be used for any type of code coverage tools that you're using, or even for the test execution as well. I didn't mention it, but all those fields that you saw before were from a play rate test, but whatever tool that you're using, you can use these same mechanisms. For code coverage, we have two groups of fields that we're tracking. Again, this is not an extensive list. And in the first group, we have coverage, how much of our code gets actually tested with tests, covered, and that means the instructions or code that are exercised by tests, and missed is, again, instructions or lines that are not covered by a test. And these things need to have some context, right? So we added this second group of fields. Which release is this coverage for? For which repository? And again, really important, like for which team? In this case, we connect plain numbers of coverage with actual releases, with actual work, and with actual teams. So now that we know what type of data we can track, we need to send it over to our observability platform of choice. And basically, this is like building a bridge from your tools to your observability platform. And you have two main ways or two main paths to do this. You could either use your vendor API integration, right? And this is fast and simple. It's like the highway straight to your observability platform. You just add your data in your scripts or your tests, send it over with the API, and boom, that's it, instantly connected with your observability platform. And the second way is using OpenTelemetry. OpenTelemetry is the universal language for observability. It's an open source project, and it's fast and portable. So let's take a quick look at how you would do it with your vendor API integration. In this case, you will just get your service, package all your data, and using a vendor's API like New Relic or any other tool provide this sort of API. You will send that data directly to your observability platform. And this is a nice way if you're already using some of these tools. It's fast and easy, but there's a trade-off, and that's that you are logged into that environment, into that vendor. If you use OpenTelemetry, the workflow is a bit different. You will need to add the OpenTelemetry SDK to your service, and with the collector, send that data to multiple tools. So this is really interesting if you need to send your test data to multiple backends, or if you want a future-proof solution. The trade-off here is that it requires more work. It takes a little more, you need to give it a little more love to have this setup, but again, it will be future-proof. So in a nutshell, whichever path you want to choose, you will always have a triggering event, a merge to master, or when a test finishes, to start the data collection. You will send that data directly to your observability tool, either via an API or with the OpenTelemetry SDK, and you will have it available for debugging and starting getting those answers for your questions. So before starting, I want to tell you a little more about my job. I work as a test architect at New Relic. And I would say mostly as a quality coach. In New Relic, we don't have dedicated testers on our teams. So basically, I work with engineering teams to improve their testing processes, their testing practices, and keeping the test systems running. So you can imagine I have a lot of work to do. One of the first things that I worked at New Relic was setting up end-to-end tests, UI end-to-end testing. So we started working with Playwright a couple of years ago. And at the beginning, everything was smooth, really nice. But then eventually, the most hated problem showed up. Can you guess? Yes. Yes, I didn't need to talk about it. Yes. Flaky tests. The worst nightmare, right? If you work at test automation, you heard it before. Playwright is flaky, Selenium is flaky, my platform is flaky. It's a mess. A flaky test is a test that fails randomly without any reason. You run it once, it passes, you run it again, it fails. There was no code changes, it just blows your mind. We started seeing these things happening more and more. And the worst thing was that all the love that we have, like building this end-to-end test, was getting lost. Like developers were losing confidence in our test suite. So we needed to act as soon as possible. And in order to do that, we needed data. And remember, I talked about a group of fields that we track for test executions. There's this one in particular, the outcome field, that is pretty interesting for us. The outcome field tells you a little more than if a test passed or failed. In Playwright, a test case outcome can have 4 different states. And the one that we're interested in is the flaky state. So you get this for free. And you have it available in your observability platform if you track it. So if a test fails and then passes on a retry, this is automatically marked as flaky. And we have that data, right? So it was time to build a plan for attacking this issue. First, we will research, like understand when do we have these flaky tests, how much, what's the percentage, what teams, etc. Then we will implement a fix, and this fix could be anything like fixing your test code or fixing your application, your environments, and whatnot. And last, we would like to measure success, if it's actually worked, our strategy actually worked. And this feels a bit like science, right? We would like to test our hypothesis before claiming success. And really is in steps 1 and 3 where observability will make us faster and better, because we will use real data to spot real issues and real results to claim success. So now that we have everything together, we went into a room with a lot of tech leads, engineers, managers, etc. Started brainstorming what to do with flaky tests. And we said, we need to access the data, right? We need the things that we are already tracking on the database before actually implementing fixes. And in the past, this was like a nightmare, because you have all the test data flowing around in different tools, in Jenkins, logs, and builds, and whatnot. But since we have everything in one place, we get better and faster results. Little disclaimer, all my examples will be based in New Relic because this is the place I work, and this is the tool that I know the most. But all other vendor tools also offer similar ways to query your data. So this is a New Relic query language example. And in this case, we are asking the question, how many flaky tests did we have last week grouped by browser? So when we hit enter, we get the result back. In this case, we can see a pie chart. And it's clear that Chromium has the most amount of flaky tests compared to the other browsers in this example. So maybe that's something that we would like to dig a little deeper into. So we start adding more parameters to our query. In this case, we add the browser name, Chromium. And since we are researching flakiness, we also would like to see the actual error messages that we got for those flaky tests. We add those parameters, hit enter, and boom. No more guessing, no more searching through dozens of tools. This is just text and numbers. The actual error messages, how many times did we have those errors for flaky tests? And what we can see is that we had two main reasons for flakiness. One, the test timeout, waiting for something to show up on the screen. And the second one is that just the entire test took too long, right? OK, so now we have all the data, all the information. We were in the room, started brainstorming what to do about it. And someone said, just take the flaky tests and throw them to the teams that wrote them. That's it. We all know that's probably one of the worst things that we can do. We scratched that. So some other folks said, let's do something. We could fix the test, but it will take too long. Maybe we just ignore it, put it aside, but that will be too noisy. Let's delete the test, right? Flakiness solved, that's it, smart move. We didn't do this. Actually, we had a strategy to deal with this, and after checking the test and the exact situation, we were using different weighting strategies for pay rate, and we didn't follow the best practices for it. So we worked with teams to fix this situation. We were also not using page objects, so we implemented that for easier code reuse and maintenance. And we started with one team. And we started seeing results, so the others would like to organically follow, right? And since we started seeing good results, we wanted to share this with everyone. And to do that, we used dashboards. And the dashboard is just a visual representation of all your data at a glance. Each one of these visualizations is powered by a query just like the one we saw before. And it will help you spot patterns real quick, like spikes in bugs or continuous improvement. But what's more important is that when teams start building their own dashboards for test data, they start getting a sense of ownership and continuous improvement. So we started this strategy, created the dashboards. A lot of teams followed organically, and then it was time to measure our results. And to do that, we ran a query pretty similar to this one. Our question was, what's the percentage of flaky tests that we have in our end-to-end test suite since May till September? And we expected this trend to go down. If flakiness was going down, our strategy was working fine. If not, we need to do something differently. So we ran the query and get this result back. And in this bar chart, you can see that there's a trend going down for flakiness. It means that our strategy was working. We are making progress. We're moving ahead. And in the end, these were our results. We started with around 5% flakiness for all our test executions, and we ended up with less than 1%. And what these numbers mean for us is that our teams can now stop doing pointless work and start adding more value to our customers, creating new features, and just being happy without flaky tests. So how's your energy level going? All good? Are we good? You want to stretch a little? like, oh, it's early in the morning. Maybe do some rolls like this. Yeah. We are all waiting for the morning tea, right? I'm a little hungry. So let's move to the final story of the day. I would like to know, do we have QA managers in the room? Could you raise your hand? Okay. Keep your hand raised if you're actually tracking code coverage for the teams that you work with. Yeah. We know as leaders that when you want to track this type of data, you need to have it right. And in New Relic, we track a lot of services, different teams. We work with entire groups of engineering organizations. So we wanted to have everything in one tool. So in the same vein, we can start asking questions about coverage. And in this case, we want to see what's the average code coverage for this particular team. Let's say it's one of your teams. We hit the query. We get 90% coverage. Super cool. This is something that we all want to achieve. By the way, this is the aggregated code coverage for all the repositories or projects that this team owns, right? But if you want to be more granular, you can. So you just need to add more parameters to your query, like maybe an actual project or repository that you're interested in. And since we work with a platform engineering mindset, we can build dashboards for all teams. There's no need for each team to build their own dashboard. And in this case, you can see a dashboard for a team. But if you see in the top right, I think, there's a drop-down there, the teams. This is where we use something called template variables. So if you're interested in one particular team, you just select it there, and the dashboard will refresh with the right data. We also track group names for coverage. This is something that I didn't mention. And a group is basically a group of engineering teams, like teams that work in backend, UI, etc. And this is really interesting for, let's say, directors or people that would like to have a broader view of code coverage to spot patterns. And in the same way, we build dashboards using template variables. These directors or VPs can just click there, select their group, and find this data. But data won't solve all your problems, right? How much code coverage is enough? Is it actually worth it to track? I don't have that answer. Maybe we can discuss it later throughout the conference. And let's be honest. I know that you thought of these type of memes when I started talking about test coverage or code coverage. We all know that an application with 100% code coverage doesn't mean that it's perfectly tested, right? And like any metric, it can be game. But I still think it's nice data to have in your tool belt. For me, it's really interesting to understand if a team has between 0 to 20% test coverage, let's say. Far more interesting than understanding if a team has more than 80 or if they are reaching 100%. We can use this as data points to start conversations, to understand if we have tech debt that can be solved in our testing strategy. So it's time to open the box. Are we ready? Yes. I need you to help me with the countdown. From 5, okay? 5, 4, 3, 2, 1. Now it's your turn to define what data is important for getting your answers and send it over to the observability tool of choice. To keep it simple, don't overcomplicate it. You can start small and iterate as you go. Don't wait for perfection. And if you want to take home one idea from today, is that all this data and numbers and metrics and log doesn't mean much if they don't spark conversations with your teams. Let's use this data as a collaboration tool. You are in control of what you observe, and that power is yours to unlock. Thank you.